Hello and welcome to my first part of circuits revision. Now, I know a lot of you were expecting Half-Life Part 2. I'm sorry, I'm going to be uploading that soon. I've been asked an awful lot for this one for current, so I thought I'd get that out of the way. So this is part one. Part one, we're going to be focusing on current in the series and parallel circuit and resistors. And then in part two, we're going to be working on potential difference across components in the series circuit and the parallel circuit. So, first off, let's go through the first three of Kirchhoff's laws, which concern current. The first one is that in a series circuit, current is constant. Now, what that means is that no matter where you are in the circuit, the current will always be the same value. A good example of this, if we just put that into a circuit diagram, we have our cell, ammeter, we're going to call it ammeter 1, resistor, ammeter 2, and a complete circuit, a very simple problem. Now, if the cell has a potential difference of 10 volts, and the resistor has a resistance of 5 ohms, we need to find the current at both A1 and A2. Now, in order to find the current going through the circuit, we need to use Ohm's law, V equals IR. Now, we need to rearrange this to make I the subject. You can just do a simple rearrangement using a triangle, which looks like so. V, I, R, we're looking for I, so we cross that out, and it tells us it's V divided by R. But a better way, which is what I prefer, is just standard rearrangement, which is if we divide by R on both sides, we get V over R equals I R over R. The R's cancel, therefore I equals V over R. Now, if we want to find the current of this particular circuit, we use I equals V over R equals 10 volts over 5 ohms equals 2 amps. Now, some of you might be thinking, but what have we just worked out? Have we worked out A1 or A2? Well, because of this Kirchhoff's law, we've actually worked out both. Both A1 and A2 are 2 amps. Okay, let's just get a board rubber and move on to the next part. So we've talked about current in a series circuit. What about a parallel circuit? Well, in a parallel circuit, current is split between each branch and rejoins when the branches rejoin. I'll show you what I mean. You might want to take that down, pause the video, feel free, but I need to just draw the diagram, so obviously I'll need a bit more space. So, let's say we had a parallel circuit like so. Again, we've got our cell, we've got ammeter 1, then we have our first branch with ammeter 2 and a resistor, and our second branch with ammeter 3 and another resistor. I do apologise, I forgot to draw another ammeter there, which is A4. And we need to find A1, A2, A3 and A4. The values given is that the power supply is 10 volts, we have a 2 ohm resistor on this branch and a 5 ohm resistor on this branch. Now, going back to our first law, because we can pretty much section all this off as what we call the load of the circuit, we can actually say that A1 and A4 is almost as if they are in a series circuit, whereas this is just one great big mess of resistors, etc., that just can be treated as one big resistor. You're actually going to learn more about that in further electronics. So we can say that according to the first law, A1 and A4 are going to be the same. We'll just get rid of that rectangle and go back to the diagram as we were. So We first need to find out what A2 and A3 are. Now, that is using a rule that we are going to come across later. That potential difference of the cell is going to be the same as the potential difference across each branch. So the potential difference, so for A2, the potential difference is 10 volts, and the resistance is 2 ohms. So we're using the same equation again. I equals V over R equals 10 over 2 equals 5 amps. Remember your units. And for A3, same again. V is equal to 10 volts, but resistance this time is 5 ohms. So we get I equals V over R equals 10 over 5 equals 2 amps. Okay, so what about A1 and A4? Well, according to the rule that we just visited, the current splits when we reach this part, when the branches split and come back together, when the branches come back together. That further supports A1 is equal to A4. What it also supports is that the sum of A2 and A3 is equal to whatever A1 and A4 is. So we can find A1 and A4 by simply adding together A2 and A3. In other words, we find the current going into and out of the power supply by summing together the current on each branch. So A1 equals A4 equals A2 plus A3. A2, as we just worked out, is 5 amps. A3, as we just worked out, is 2 amps, which is 7 amps. And there we go. Not too difficult once you know how. The third rule we're going to look at, so you may want to take this down. Please feel free to pause the video. Okie dokie then. Okay. The last one is that resistors, we're going to talk about is resistors in series. So resistors in series add together basically. So if we want to find the total resistance of a circuit, we add together the resistances of every component in said circuit. For example, again, we've got a 10 volt power supply with an ammeter, 2 resistors this time, 5 ohms and 2 ohms. Let's say that we wanted to find the current. Well, to find the current, we need to find the resistance of the circuit. These 2 resistors work together to make one resistance R1, which in this case, R1 is equal to 5 plus 2. So the total resistance of this circuit is the sum of these 2 resistors in series, which equals 7 ohms. Therefore, we can find the current A is worked out using I equals V over R equals 10 over 7. 10 over 7, I will just very quickly have to grab a calculator because my mental math is not working at the moment. Uh, 10 divided by 7 equals 1.4. Okay then. Well, that's the explanation part finished. Now we just need to give a question a go which combines all of these. Now this is the level that you'd usually find at GCSE. So we're going to have a parallel circuit. So start off with our 10 volt power supply. It's going to go down into A1 and A2. We have a 5 ohm resistor here. Another ammeter over here, but this ammeter you've been given the value of 7 amps. Third ammeter over here with a 1 ohm resistor and a second resistor which we don't know, so we're going to call R. Please excuse me while I extend that circuit. That's still fine, still exactly the same as it was before. I just ran out of space really. So if you'd like to pause the video and give this a go, see if you can find A1, A2, A3 and R. I'll go through the answer as soon as you click play. Okay then, so hopefully you've given that a go. Should not have found that too difficult, but let's give it a whirl. The first thing you can do straight away is tell me what A1 is. If we have an ammeter over here and an ammeter over here, the current is the same before and after the split, if you like. So A1 equals 7 amps. That's probably the easiest one you'll find on here. The next part is to find A2. Well, going back to what we said before, the potential difference across the cell is the same as potential difference across each branch. So to find A2, we're going to be doing I equals V over R equals 10 over 5 equals 2 amps. Okay then, now you've got A1 and A2, or now you've got A2 and this original value we were given here, same difference. We will now know what A3 is because of our second rule, that the currents come back together and sum up to 7. If we've got 2 amps and an unknown value that add together to make 7, we know that unknown value must be 7 take away 2, which is 5 amps. So A3 equals 5 amps, and that leaves us with R. Now, again, we've got a current, we've got a potential difference, which is 10, we've got some resistances here. So to find that one, we first must find what the total resistance of this branch is. So for R, we're going to use R equals V over I, which is another rearrangement of Ohm's law. That equals 10 divided by what we found the current to be, which is 5. Yep, that's perfectly fine. So that's 2 ohms. Now that's 2 ohms for the entire resistance. So if we were to replace this one big fat resistor, that would be 2 ohms. So that tells us that if these two add together to make 2 ohms and one of them is 1 ohm, therefore R equals 2 take 1 equals 1 ohm. So to conclude, A1 is 7 amps, A2, as we worked out, is 2 amps, therefore A3 must be 5 amps, and R, according to what we've just worked out, must be 1 ohm. I hope you found this useful. Please tune in for part 2 when we will be looking at the potential difference in series and parallel circuits.